Okay, looking at 6.3, number 13, says write an inequality that represents the statement and graph the inequality. So the statement in this problem is x is greater than, I'm reading this out of the book, it's an actual sentence, x is greater than 7 or less than 5. So x is greater than 7 or less than 5. When you have an or statement, you've got two separate things, and one example that I try to reach kids with is that if your parents say you can unload the dishwasher or clean your room, you know you've got two separate tasks and you can pick one. That's not to be confused in class that one student actually made the mistake of thinking that they just had to do one of these, that was all they had to do. They're getting the analogy or the metaphor mixed up with reality. I want them to do the whole problem. So, when x is greater than 7 or x less than 5, if you're going to graph that, it's going to be 5 and 7 involved in there. So we got 5, 6, 7, and I recommend when you're making your number lines that you kind of go at least one notch past the numbers of interest, which in this case we're saying 7, x greater than 7, it's not also equal to the 7. If it had this, then it would be a closed circle, but because it's just greater than 7, we leave an open circle. That's indicating that it's starts at 7 and is greater than, x is greater than 7, but not including the 7. So that's why we have an open circle there. And go ahead and darken in a nice arrow going greater. So all numbers satisfy x if they're greater than 7, not equal, because if we put a 7 right there, we've got a false statement. 7 is not greater than 7. So that's why it's an open circle. Now x less than 5, you do the same thing, an open circle and less than. When you make your arrows on your paper, please shade a nice thick arrow to show me so it's easier for my eyes to see what's going on. So that's how you graph an OR statement for number 13.